Today, we are answering an age-old, very scientific, and incredibly important question. What if the moon crashes into Earth? It's more interesting and weirder than you probably think. Let's start with the basics. Why isn't the moon already on its way to crash into us? We know that Earth's gravity pulls everything toward it, including the moon, but somehow it stays up, as if suspended by some opposite force. But there is no opposite force. The trick to staying up is a sideways motion. We call it an orbit. You see orbits every day. When you throw a ball, it makes a tiny little orbit. The only difference between that ball's orbit and the moon's, the ball eventually hits the ground. The reason? Speed. If you could throw your ball fast enough, it would bend around the world and come back to you. If there was no air slowing it down, it could orbit forever. And this is what the moon does, falling sideways around Earth, very fast, with no air slowing it down, orbiting Earth every 27 days at 3,600 kilometers per hour. So, for the moon to just stop in its orbit and plummet to Earth, that would break more laws of physics than we have time to explain. So, how do we crash it into Earth? In a nutshell, to change an object's orbit, you need to change its speed, which changes where gravity takes it. But even small changes require enormous forces. The moon is big and very massive. Even igniting billions of rocket engines all over its surface would barely move it. It looks like nothing short of magic will make the moon fall. So, we'll use a magic spell, one that slows the moon down so much that it spirals toward Earth. And to get the most from the experience, the moon will take exactly 1 year before it hits. Ready? 3, 2, 1.
If this cosmic disaster feels real, that's because we spent months making sure the science was right. Every tidal wave, every earthquake, every volcanic eruption in this video is based on real physics, not Hollywood magic. And that kind of research takes time, a lot of it. So if you want to help us keep creating videos like this, exploring the biggest what-ifs the universe has to offer, there's one simple thing you can do. Hit the like button, subscribe to join us on every journey, and turn on notifications so you never miss a moment of cosmic chaos. It costs you nothing, but it means everything to us.
Month 1. For the first few days, nothing really changes. The moon gets a tiny bit brighter, scientists get confused, but the rest of us don't notice anything different. The only noticeable real effect of the moon on Earth, the tides. Tides exist because while Earth pulls on the moon's gravity pulls back on Earth. Since gravity gets weaker with distance, different parts of Earth feel a slightly different pull. This causes Earth, especially the oceans, to bulge when the moon is above them. But with the moon drawing ever closer, high tide gets higher every day. At first, barely noticeable. Within a month, the moon has covered half the distance to Earth. Ocean tides have grown to 4 meters. Every day high tide comes, and waves flood coastal cities, and there is no end in sight. Month 2. By the end of month 2, the moon has covered 2/3 of the distance to Earth. Global infrastructure is crumbling. Tides rise above 10 meters, displacing up to 1 billion people who happen to live near coastlines. As ports become inoperable, shipping grinds to a halt. Not only will it slow down the delivery of Factalab products, but also less exciting things, like food. Global communications fall into disarray. 95% of the internet is carried by ocean-crossing cables. While these don't mind the water, their terminals on land do. Living inland doesn't guarantee safety either. Tidal bores cause rivers to flow backward, carrying salt water to contaminate surface and groundwater supplies. Gas shortages follow. Oil refineries near the coast are abandoned. Countries are left with whatever supplies they had on their shelves. Strict rationing begins. In the cities, chaos reigns during the scavenging hours of low tide, while survivors take refuge in high-rises when the water returns. Month 3. 3 months in, and the moon is close enough to disrupt communication and navigation satellites. The closer it gets, the more warped their orbits become. As fuel for orbital corrections runs out, satellites careen out of control. Months 4 and 5. On Earth, tides are rapidly growing to about 30 meters and will reach 100 meters in a few short weeks. At low tide, the ocean recedes hundreds of kilometers, exposing the continental shelf like vast deserts. At high tide, walls of water drown agriculture, houses, and skyscrapers. And now, almost 5 months in, the apocalypse has finished its warm-up act. Since the oceans are on average only 3 kilometers deep, the tides have reached their maximum. Up until now, the water could flow, absorbing most of the moon's gravitational squeezing. But now, the Earth itself is feeling the squeeze. These aren't so much tides of water anymore, they're tides of rock. The squeezing of the planet, combined with the weight of quintillions of tons of water sloshing on and off the tectonic plates, creates enormous stresses below. It begins to cause earthquakes of increasing magnitude and intensity. It's impossible to say how serious these earthquakes might be or where they occur, but like a child jumping on their bed until it breaks, no good can come of it. Strong tidal forces lead to volcanism on other planets and moons. On Earth, squeezing the planet disrupts magma reservoirs inside the crust, triggering sizable climate-altering eruptions. Chile, New Zealand, Yellowstone, elsewhere. Meanwhile, watching patiently above is the moon, still no bigger in the sky than a small cloud. Within 75,000 kilometers of Earth, it's bright enough to illuminate the night sky like twilight. Months 6 and 7. After half a year, the moon enters the space once occupied by geosynchronous satellites. It orbits Earth every 24 hours. It appears to float at one spot in the sky, unmoving. Cycling through a full set of phases every day, but only visible to half the planet. With the moon stationary above Earth, the tides seem to freeze in place. Half the world flooded, half with its water seemingly returned to the sea, as if Earth is holding its breath to prepare for the worst. As the moon sinks further, you might wonder, would its gravity overpower Earth's, pull you up and end your misery? Fortunately, no. Earth's surface gravity is about 6 times stronger than the moon's, so even if the moon were hovering right on top of you, you'd still stay on the ground. On the moon, things are different. The near side is more strongly affected by Earth's gravity. Over the next few months, it starts to stretch forward toward Earth,
into something of an egg, triggering deep moonquakes as lunar rock flexes and changes shape. Though barely noticeable now, this squish will grow to hundreds of kilometers in a matter of months.
Months 8 through 11. At this point, the apocalypse has arrived. We can summarize the months before the crash as everybody left has a really bad time. The tides sweeping over Earth slow down, then reverse direction, because the moon now orbits Earth faster than it rotates. The planet experiences an abundance of earthquakes and volcanism. Massive amounts of volcanic aerosols rise high into the stratosphere, shiny enough to reflect sunlight back into space. What little light gets through is rust red, periodically diminished by daily eclipses. The result? Rapid global cooling, acid rains, summer snows, killing even the hardiest plants. The clock runs out on civilization. Billions have perished, while an egg-shaped moon still draws closer. Let's get ready for the grand finale.
Month 12. Finally, at the end of the year, the moon has reached the Roche limit. That's the point where Earth's gravitational pull on the moon is stronger than the moon's own gravity. Things on the lunar surface start falling toward Earth. By the time it crosses 10,000 kilometers, the entire moon disintegrates into rubble, smearing itself into a massive ring system around Earth. Fortunately, the moon's disintegration means the misery on Earth has ended. No moon means the general apocalyptic nature of things comes to a halt. The oceans recede, flowing off the land one last time. Any survivors are treated to a view of tremendous arches spanning the sky, glimmering in the sunlight, illuminating the night sky more brilliantly than any full moon ever could, while meteor showers of moon dust fill the sky.
What happens next? It's hard to say what happens next, but the tranquility may be short-lived. If too much moon dust rains down, friction heats the atmosphere, possibly boiling the oceans. If not, the enormous shadows cast by the rings, combined with all the volcanic and meteoric aerosols, block even more sunlight. A period of runaway cooling could begin that freezes much of Earth's surface solid. In any case, at some point people will emerge again, from submarines or bunkers or mountaintops. They will not have a great time before rebuilding civilization, and their success is not guaranteed. But at least they will try to do so with beautiful rings in the sky.
The moon is gone, but its rings remain, a beautiful reminder of what was lost and what was survived. This video took months to create. Every frame, every fact, every second of this journey was crafted with one goal: to make science feel as epic as it really is. If that matters to you, if you believe that curiosity should be celebrated, then the most powerful thing you can do is share this video. Send it to a friend. Post it on social media. Help us keep this channel alive and independent. The moon may never fall, but your support, that's what keeps us going. Thank you for watching. Thank you for subscribing. And thank you for exploring the cosmos with us. See you in the next What If. It costs you nothing, but it means everything to us.